Welcome to Linear Equations Level 5. Pause the video now, have a go at the 3 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving y equals 4 minus x and y equals x squared plus 3x minus 1. Now, since we have a nonlinear and a linear equation here, we need to solve these by substitution. And here we can take the linear equation y equals 4 minus x and replace the y in the nonlinear equation with 4 minus x from the linear one. So what this means is that the second equation y equals x squared plus 3x minus 1 becomes 4 minus x, because we've substituted the y for 4 minus x, is equal to x squared plus 3x minus 1. Now we've got a quadratic that's in terms of x, and so we want to make one side equal to 0. And the easiest way to do this is to look at the left and remove this 4 by subtracting 4 from the left, and we need to make sure that we do the same on the right, and then removing the minus x by adding x to the left and doing exactly the same on the right. And on the left, the 4, the minus 4, the minus x and the plus x all cancel out to just leave 0. And on the right, we have x squared, 3x plus x gives us plus 4x, and minus 1 minus 4 is minus 5. Now, when we solve quadratic equations that just have an x squared at the start, it tends to be easiest to try and factorise first. So we're going to try and factorise the expression on the right. And we can do this by looking for two numbers that multiply to make minus 5 and add to make 4. And those two numbers are 5 and minus 1, because 5 multiplied by minus 1 is minus 5, and 5 added to minus 1 is 4. So this equation becomes 0 is equal to, and when we factorise, we're going to have two brackets. We're going to have an x at the start of each, because x times x gives us x squared, and our two numbers 5 and minus 1 go at the end of our bracket. So we have x plus 5 and x minus 1. Now, since these two brackets are multiplying together to make 0, what that means is one of the two brackets needs to be 0. So either x plus 5 is 0 or x minus 1 is 0. And we can now solve each of these independently. So starting with x plus 5 equals 0, we can subtract 5 from the left to remove the plus 5 and do the same on the right. And this gives us x is equal to minus 5. Looking at the other equation, x minus 1 equals 0, we can remove the minus 1 by adding 1 to the left and also to the right, and this gives us x is equal to 1. To find the corresponding values of y, we're going to take the first equation, y equals 4 minus x, because this looks much easier to use than the second one. I'm going to substitute our 2x values in here one at a time. So when x is equal to minus 5, this equation becomes y equals 4 minus 5. And this minus in the middle is equivalent to a plus. So we have y equals 4 plus 5, which means y is equal to 9. So these form our first pair. If we now move on to when x is equal to 1, and using the same equation, we have y is equal to 4 minus 1, and 4 minus 1 is 3, so y equals 3, and this is our second pair. And so our final answer to problem 1 is x is equal to minus 5, y is equal to 9, that's our first pair, and then x is equal to 1, y is equal to 3 gives us our second pair. In problem 2, we're solving x squared plus y squared equals 29 and y equals 3x plus 1. So again here we have a linear and a non-linear equation, so we're going to solve these by substitution. Now looking at the second equation, which is written with y as a subject, we can take 3x plus 1, which we know is equal to y, and substitute it in place of y in the first equation. So the first equation, x squared plus y squared is equal to 29, becomes x squared plus, and then in brackets we're replacing the y with 3x plus 1, and we have to square that, and that's equal to 29. We now have an equation that's just in terms of x, so we can expand, simplify, rearrange, and hopefully solve. Now looking at the brackets, we want to expand those. So to expand a bracket that's being squared, we're going to multiply that bracket, 3x plus 1, by itself. And that's equal to 29. So we now have x squared, 3x multiplied by 3x is plus 9x squared, and 3x multiplied by 1 is plus 3x. We then have 1 multiplied by 3x, which is plus 3x, and 1 multiplied by 1, which is plus 1, and that's equal to 29. We can now simplify the left by collecting together the like terms. So we have a 1x squared plus 9x squared, which gives us 10x squared. We have plus 3x, which is plus 6x, and we have a plus 1 at the end, and that's equal to 29. Again, when we're solving quadratics, we want one side to be equal to 0. So we can remove the 29 on the right by subtracting 29 from the right and doing exactly the same on the left. And this gives us 10x squared plus 6x. 1 take away 29 is minus 28, and that's equal to 0. Now, whenever we have a number in front of the x squared that's not a 1, it tends to be easier to use a quadratic formula unless we can divide through to remove that number. Now, at the moment, we can divide every term by 2, but that's still not going to give us a 1x squared. So I'm going to leave this quadratic as it is and use the quadratic formula. Now, before we can use a quadratic formula, we need to write down our values of a, b, and c. So a is always a number in front of the x squared, which in this case is 10. b is a number in front of the x, which is 6. And c is the constant or the number at the end that's on its own. So that's minus 28. So we can now substitute these values into the quadratic formula, and we get x is equal to, so we have minus b on the numerator, so that's minus 6, plus or minus the square root of b squared, so that's 6 squared, minus 4, multiplied by a, which is 10, multiplied by c, which is minus 28, and that's all divided by 2a, which is 2 times 10. And if we put this into our calculator with a plus on the numerator, we get that x is equal to 7 over 5, or 1.4. And if we do the same, but using a minus on the numerator instead of a plus, we get x is equal to minus 2. So these form the first part of our solution. We now need to find the corresponding values of y. So we're going to take the second equation, y equals 3x plus 1, because this is simple to use and y is the subject, and we're going to substitute each of those x values in one at a time. So when x is equal to 7 over 5, y is equal to 3 multiplied by 7 over 5 plus 1. And since 3 multiplied by 7 over 5 plus 1 gives us 26 over 5, y is equal to 26 over 5, and this is our first pair. We can now substitute x equals minus 2 into the same equation. So we have y equals 3 times minus 2 plus 1. And here 3 times minus 2 is minus 6, plus 1 is minus 5. So y is equal to minus 5, and this is our second pair. So our final answer to problem 2 is x equals 7 over 5, y equals 26 over 5, and x equals minus 2, y equals minus 5. In problem 3, we're solving y squared plus xy equals 3 and x equals 3y minus 2. Now again, we have a nonlinear and a linear equation here, so we're going to solve these by substitution. So I'm going to go to the simpler equation, which is the linear one, and I'm going to take 3y minus 2 from here, and since I know this is equal to x, I'm going to replace the x in the first equation with 3y minus 2. So the first equation, y squared plus xy is equal to 3, becomes y squared plus 3y minus 2 multiplied by y is equal to 3. This equation is now just in terms of y, so we can expand, simplify, and solve. So to expand the brackets, we have y squared plus, and then 3y multiplied by y is 3y squared, and minus 2 multiplied by y is minus 2y, and that's equal to 3. We can now simplify the left side by collecting together the 1y squared and the 3y squared, and we have 4y squared minus 2y is equal to 3. To solve this quadratic, we want the right side to be equal to 0, so we're going to subtract 3 from this side and do the same from the left, and we have 4y squared minus 2y minus 3 is equal to 0. Now, since there's a number in front of the y squared here that's not 1, it tends to be easiest to use the quadratic formula. You could of course try factorising or try other methods, but I'm going to go with the quadratic formula here. And before we can use this formula, we need to first establish the values of a, b, and c. So a is a number in front of the y squared, which is 4 here. B is a number in front of the y, which is minus 2. and c is the constant at the end, which is -3. So we can now substitute these values into the quadratic formula, and they give y, because our equation is in terms of y, is equal to minus b, so that's minus minus 2, which is 2, plus or minus the square root of b squared. Now, because b is negative, we need to make sure this goes in brackets when we square it, minus 4 multiplied by a, which is 4, multiplied by c, which is -3, all divided by 2a, so 2 times 4. And if we put this into our calculator, we get our first value of y when we use plus on our numerator as 1.15, correct to 3 significant figures. If we do this again, but using a minus on the numerator instead of a plus, we get y is equal to minus 0.651, correct to 3 significant figures. And so we have the first part of our solution. To find the matching values of x, we're now going to take the second equation, the linear one, x equals 3y minus 2, because x is already the subject, and we're going to substitute our values of y into this equation. So when y is equal to 1.15, we have x is equal to 3 times 1.15 minus 2. And if we put that into our calculator using the exact value of y, we get 1.45, correct to 3 significant figures. So this gives us our first pair. If we now take y as minus 0.651 and we substitute it into x equals 3y minus 2, we get x equals 3 times minus 0.651 minus 2. And this gives us minus 3.95, correct to 3 significant figures. So this is our second pair. So our final answer to problem 3 is x is equal to 1.45, y is equal to 1.15, and x is equal to minus 3.95, y is equal to minus 0.651.